Good morning. So the topic for the day is basic concepts and laws of mechanics. I am E. Ilavenil, Assistant Professor, Department of Mechanical Engineering, Thandai Periyar Government Institute of Technology, Vellore. So at first we see two very basic terms. The first one is space. So space is the geometric region occupied by bodies whose positions are described by linear and angular measurements relative to a coordinate system. The next one is time. Time is the measure of the succession of events and is a basic quantity in mechanics. Mass. Mass is a measure of inertia of a body, which is its resistance to a change of velocity. Mass can also be thought of as a quantity of matter in a body. Force. Force is the action of one body on another. A force tends to move a body in its direction of its action. The action of a force is characterized by its magnitude, its direction of action, and by its point of application. Engineering idealization. So, in a previous lecture, we have seen what engineering mechanics is and how we have certain considerations for engineering. So a very important such a consideration is the engineering idealization. So here we study engineering mechanics under two broad titles: mechanics of particles and mechanics of rigid bodies. That is, totally we classify bodies as particles or rigid bodies. So the first one, particle, is a body of negligible dimensions. It is a mass concentrated at a point. So we may consider a body as a particle when its dimensions are not important to the problem studied. So in engineering, we have certain problems where we consider the dimensions of a body to be important or not. So when they are not important, we call that body as a particle. So in statics, a body with all forces being concurrent can be treated as a particle. In dynamics, a body whose rotations are not significant can be treated as a particle. So examples of particles. So a hook subjected to several forces through ropes is considered as a particle, though it has several dimensions. For engineering problems, it can be represented through a single point. So a bus traveling from one place to another. Of course, a bus can also be considered as a rigid body in certain other types of problems. But when we say a bus is traveling from Vellore bus stand to Coimbatore bus stand, we just represent it as a point in the map. Do we ever consider whether the bus is turning towards the east at Vellore bus stand or towards the west, and how, in which direction it is going to reach Coimbatore bus stand? Never. It starts here and ends there, and it can be totally considered as a point rather than a rigid body whose directions, whose rotations are all significant at all. Again, a planet revolving around the sun. When you study its position, we normally mark the orbit through a line and the planet through a dot or maybe even a larger circle, but still when we don't consider its rotation, its position can be marked as the center of that circle. That is where we represent the position of the planet, and that should be sufficient. Hence, even though the body is as large as a planet or maybe even a sun or a star, it can be considered as a particle for those engineering problems where we study the path of its travel. Rigid body idealization. So a body can sometimes be termed as a rigid body. Originally, rigid body is a body that cannot be deformed by the application of forces. That is what we consider absolute rigidity, that a body cannot be deformed at all, whatever may be the force. Basically, rigidity is the property which resists the deformation. So a body is considered rigid when the change in distance between any two of its points is negligible in our problem. That is what we could call practically a body as a rigid body. But still, this engineering idealization is not just about rigidity, it is about that non-deformable body, whether it has any non-concurrent force or whether it has any moment applied upon it. So it is all about whether a body is a particle or not. If a body is not a particle under engineering mechanics, it is referred to as rigid body. So in engineering mechanics, we only have two types of bodies. One is particle, another one is rigid body. So we have deformable bodies and all. We don't study them under engineering mechanics. We will be studying that under different topics that are strength of material or mechanics of solids, or else fluid mechanics, gas dynamics and all. Okay, so here under the topic engineering mechanics, we only have two types of bodies: particle, rigid body. So examples of rigid body. So a beam subjected to several forces. So we all could have seen beams in our houses or various building structures. A beam is usually a horizontal member subjected to lateral loads. So a truss which is subjected to several forces. A truss is a structure where a number of elements are connected through pin joints, and then we have a gear subjected to a torque, an IC engine, connecting rod, that converts force of a piston into rotation of a crank. These are typical examples of rigid bodies. Of course, these are typically rigid bodies as per engineering idealization. So here we have examples under both statics as well as dynamics. So we will also see Newton's laws under this topic. So Newton's first law. So a particle remains at rest or continues to move with uniform speed in a straight line if there is no unbalanced force acting on it. So this is Newton's first law. So the concept of inertia is based on Newton's first law. So the ability of a body to sustain its condition of rest or of uniform velocity is called as inertia. Newton's second law. The acceleration of a particle is proportional to the resultant force acting on it and is in the direction of that force. So that is Newton's second law. So the second law also states that the rate of change of momentum of a body over time is directly proportional to the force applied, and it occurs in the same direction as the applied force. So this defines mass as a measure of inertia. Newton's third law. This of course is the most popular law. Every action or force has an equal and opposite reaction, and the action and reaction are collinear. So this is Newton's third law. So in statics, this reaction is a force. So in dynamics, the reaction is a corresponding movement that can be considered as an imaginary force. Finally, we also have Newton's law of gravitation. So when two masses are there, the mutual force of attraction between those two masses or those two particles is given by the force capital F is equal to G m1 m2 by r square, where m1 and m2 are the masses of the two particles and r the distance between the centers of the particles, and G is a universal constant known as constant of gravitation. Okay. So these are the very important laws given by Newton. And finally, we have principle of transmissibility. So by this principle, when we have a force acting at a point, it acts through the line of action. So that is called as the principle of transmissibility. So these are the important basic concepts and basic laws that we study under engineering mechanics. And of course, we have more laws and more concepts to follow. So for now, we stop with this. So under this lecture, we have seen many of the basic concepts and many of the important laws of mechanics. Thank you.